record on this computer. Okay, I have already explained about the basic introduction to Lean. So one of the most important thing in Lean is trying to reduce inventory, trying to reduce the stocks, the inventory that we have in the supply, in this supply chain or in the value chain. So if you see, we can reduce variability, you can see that problems will crop up, or we can see like no late deliveries, process time, downtime, remove, and so on. So this is the concept of making the process lean, process and also the value chain lean. There are many tools that is required for the organization to say they are actually practicing lean. And one of them is, how to reduce inventory, okay? But inventory will uncover the rocks. Problems are going to be exposed, and ultimately there will be virtually no inventory. Not to say no inventory, we need inventory, but we need minimum inventory, just enough for production to run, or for processes or operations in services as well. Lean is not only for manufacturing, Lean is also for what they call service organizations. Even it is also implemented in government departments today, okay? Shigeo Shingo, he's a Japanese who says that inventory is evil, it's waste. Inventory is waste. So we don't want to keep too much inventory. So we need to reduce lot sizes rather than have keeping a very high inventory. Okay, inventory. So how can we reduce to a smaller lot sizes? Okay, reducing lot sizes. So we need to order more times, but we need to balance the cost as well. I think we have seen EOQ. That means we can use EOQ to do this analysis of determining the correct lot sizes. Okay, EOQ, but this is the economic production quantity, because we have this D divided by P. I'm not going to ask you to, to understand and to do the calculation. Just understand the concept that you need to actually reduce the lot sizes. So this is a method in which you can, it is to calculate setup times, how much the setup time, and how much cost. Because setup time will determine the quantity that you are going to actually produce. So in this case, this is Q star. Of course, this is the formula for the setup time. Okay. Now I'm not going to go through this, just to show you that you can do analysis, you can do some calculations. Okay, there are formulas, and you can just use the formulas to actually determine it. Okay. Right. So high setup costs encourage large lot sizes. So that's why we need to reduce setup costs. So in Toyota production system, or in Lean, there is a method called SMED. Okay, I'm not going to go too much detail on that. It is called a single minute exchange of die. Exchange of die. Die here means tools. So setup time depends on how much you can change from one production to another. For example, a part, change to a new part, change to a new stamping process. So setup time must be reduced by using this technique, single minute exchange of die, reducing setup time. Okay. So setup time can be reduced through preparation prior to shutdown and changeover. So this is what you do in single minute exchange of die. You do the preparation, then when it comes for production, you don't have to do the adjustment on the production line. You do the adjustment before. Okay, so this can reduce your setup cost. Previously, like in US automotive industry, they tried to change the stamping die process for car production. They take one day to change for a new model to be produced. But this concept was invented by the Japanese, single minute exchange of the SMED. So they managed to reduce less than 1 minute, 60 seconds and below. Okay, so that is achievement. Okay, I think we have seen this before, right? This curve. So the lower setup cost, we go further here. That means we try to actually find lower lot sizes. This is Q, right? Q. So here, lower lot sizes will give you a lower total cost. This is higher total cost. So we try to find lower setup cost, lower lot size. Q is smaller, okay? Q is smaller. All right, so theoretically it's like this, because normally all processes will have setup cost as well as holding cost for inventory. Right. So you can actually reduce setup cost. So if the initial setup cost is, for example, this is just an example from one case study, for example. So initially 90 minutes, initial setup cost. So they do step 1 to separate setup into preparation and actual setup. So you try to do as much as possible while the machine is operating. Okay, so you save 30 minutes. I mean, the machine is running, but you have an outside offline preparation. Okay, so offline preparation, when the machine stops, you put in the new die or you put in the new tool. So that can save 30 minutes. So now your setup time becomes 60 minutes. So the next step, move material nearer to the point of usage. So bring in as close as possible so that you don't have to search and, try to walk. That is waste of motion. Okay, waste of motion. And that can reduce this amount, 45 minutes, from 60 minutes reduced to 45 minutes. So you go through this process, okay? Step 3, standardize and improve the tooling. Use standard tooling, use, Pokayoke, for example. So save 15 minutes, see? So this is a systematic way of trying to reduce setup time, because the longer the setup time, the higher the setup costs, okay? And you see here, step 4, use one-touch system to eliminate adjustment. So now you go for automation. So initially it was manual, you do improvement. Then if you need to introduce, automation, electronic system, then you use one-touch system to eliminate adjustment. This will save some time, some more. You reduce that to 15 minutes. Then you train operators to standardize the work procedures. Then probably you save another 30 minutes, right? So from 90 minutes, you can reduce to 13 minutes. That's what we call as SMED, single minute exchange of die. Okay, you reduce the waste. Murah. Process, taksan murah ga arimasu yo. Many process. You just observe a process, and you repeat cycle until you get sub-minute setup is achieved. Okay. This is just an example where you can do activity, systematic step by step to reduce the setup time. Okay, in lean operations, remember Heijunka when I teach you about level scheduling? Okay, when you try to level the schedule for monthly production and then weekly production, Heijunka. So Heijunka is in lean. We have to have, say, Heijunka. If you don't have Heijunka, then you cannot fluctuate. If you fluctuate, then there is no stability. Okay, so we talk about schedule must first it must be communicated inside and outside organization because we have suppliers. We need to coordinate with suppliers, the order quantity. Then it has have to have frequent delivery. Then this level schedule, okay, this is Hejunka. Then process will have frequent small batches to be produced. And you freeze the schedule with certain time frame. 1 week, fixed schedule, 1 week fixed schedule. You cannot be changing the quantity that you have to produce daily. That you'll disrupt stability. Okay, like now COVID, well, it disrupt JIT basically. COVID is not helping JIT, okay, because it is disruption, supply chain disruption. There is no stability, okay. So that's one, the levels. And also in scheduling, you need Kanban. Kanban, as I told you last 2 weeks, is a signal to pull the material. That means if the material is already finished by the process in front of you, so you need to actually have a signal so that you can pull the lot size. For example, one lot size is 30 pieces. Then once the place or the cut is put for us to replenish, they call it replenish, okay, to replenish the stock at the next process. So we need Kanban. And normally they use cards, but you can use other means. So replenish inventory in the next process. But you don't push, okay? You don't push. Push means I have completed, I pushed forward, give to the next process. So that's not lean production. So better when you have good scheduling, so of course it will improve performance. There is very systematic, step by step, and also you will see these things happening. For example, if you want to make sure that scheduling is successful in JIT, you need to communicate schedules to suppliers. Suppliers must know how much to produce, when to produce, and when to deliver on a JIT, just in time system, okay? You make level schedule, so this Hejunka. You freeze part of the schedule, mean you fix the time frame. Okay, if it is 1 week, if it is 2 weeks, so you freeze the quantity to be produced. You cannot change abruptly, okay? And you need to perform to schedule. This is one of the most difficult thing to do in production because sometimes machine break down, sometimes, worker not attending. So that's why it is, lean is actually a perfect system. It is a system where you try to make sure it is synchronized and it follows according to the schedule. So you need to perform to schedule. Therefore, quality is important. If you deliver a part, defective parts, can the production run? Hong Li, if the parts that suppliers send, 30 units, 10 is defective, what will happen to the production line? Can they make the part? Can they continue production?
No.
No, because we have 10 defective parts in the lot. So they need to replace with a good parts that will stop the production line. So there will be, disruption, right? Like today, COVID, no parts delivery, supply chain breakdown, okay? So it's disruption. So there is no continuity, there is no smooth flow of parts and also materials. So you try to make one piece and you move one piece. That's the concept of lean, okay? JIT, just in time. Make one, pull one. Like the video you saw, last time, did the piece flow, and eliminating waste. So this is like Higo Shingo. I have a slide that I explain to you, what kind of waste exists in processes, different kind of waste. So you want to eliminate the waste. For example, you challenge when you do production from many inventory, you reduce to only one inventory. What will happen? If I only give you one piece of paper, you do a final exam or a test, I only give you one paper. You cannot ask for another paper. So what happened to you? You will try to carefully just use one paper. But if I say, okay, you can use as many papers as you want. Kami. So you throw. So mudah ada show. So only one piece, you only have that. So one piece flow. Make one perfect, pull one. Make one perfect, pull. So that is eliminate waste. So of course, to make one, the supplier also must send the good one. Then only we can make the good. So that is the thinking. So produce in small lots, use Kanbans, and make operation produce a perfect part. Okay. It's okay if you don't start with the perfect. Perfection cannot come by just first time. Perfection comes by repeated time. Practice makes perfect. There is English saying, right? Practice makes perfect. So the continuous improvement, right? This already explained just now. Okay, freezing the schedule close to the due dates can improve performance. And this is the concept. Just a concept. Okay, this is the JIT material use approach. Large lot. This is large lot. This is too much inventory. Too much to actually flow. If you need 2, you just flow 2. If you need 3, you flow 3. If you need 2, so that is the concept. Not we produce 100 cent and then you keep inventory. Not that. So you must scheduling, think about small lot scheduling. Okay, it's just a concept. Okay, it's just a flow. It's a diagram of concept. So Kanban Kanban, to go more detail on Kanban. Okay, it's a Japanese word for card. For authorization for the next container to be produced. If there is a delivery, then delivery. Okay. So a sequence of Kanban pull material through the process. Okay. And there are many sorts of signals which can be used. So today it's no more cards. It can be lights. It can be just push the button. Is online. so you can use electronics. Not necessarily, but initially a manual system is actually using cards on the pallets beside the production line. Or even space empty. When they see empty space, then you need to put in the new pallet or new lot. Okay, so many different kinds of signals. But the system is still called Kanban. Even though if you use electronic, it's electronic Kanban. But initially it started with a card. Okay, initially it started with a card, part number, part name, okay, quantity required 40. Then this is sent to the delivery person. So they will deliver that pool. This kind of this kind of like signal marker. This is Kanban basically. Okay, you will have part numbers, mark location of specific part. So this is for this specific part. Signal marker on stack of boxes. So this is showing until when it reaches here, then you need to fill up, for example. Okay, or signal marker hanging on posts. of this, So it is a signal, okay? But of course, when you say cut, that physically you must know how much to produce or how much to deliver. So there is a cut itself also, because that information, you need that information. That information must also be given to the prior process, okay? So it is a coordination. For example, so when it is finished goods is actually completed, then they want to make more. So they have this Kanban, release, cut, tell assembly, make 40. Then they make okay. So when they want to make this, they need the raw material, they need some part. So they need to actually give this. This is the assembly Kanban. This is the finished good Kanban. This is assembly Kanban. This is material Kanban. This is supplier Kanban. So Kanban connected throughout this chain. Okay, then only it is going to flow. If not, it's not going to flow. Okay, but of course, it's more complicated than this. This is just a picture. If we go to production line, automotive production line is much more complicated than this. But there are Kanbans. Okay, but it's not saying that Kanban is the only way to improve process. Some companies don't even use this. It's Toyota lean manufacturing system. Okay, it's a lean manufacturing system. You understand the concept? It's just giving information, then they are pulling. They're just you only make whatever it is required. You don't make more than what is don't make more than what is required. Okay, just make the exact quantity that is requested. Okay. I see here, even an empty spot on the floor may be adequate to become a Kanban. Okay, so it is a system. Okay, so each card will control a specific quantity. That I said just now, each card control a specific quantity of parts. Although multiple card system may be used if there are several components or if the lot size is different from the move size. So it's depending on the products, depending on the process, but it's a kind of system that actually tell, okay, I have finished, can you send? Okay, or I have 2 more to finish, please send. So by the time he sent, so 2 is already done, then I can start. So it's like rhythm. Okay, it's a smooth flow of delivery of material, parts, consumables, anything. Like in 7-Eleven or in Family Mart. So onigiri already finished. Onigiri only left 5. So they will send and fill up the onigiri or send the bread. Okay, it is a kind of that system. Okay. So Kanban cards provide a direct control and limit on the amount of, so it is actually limiting the amount of work in process between cells, between production process. So if there is a storage area, a 2-card system can be used with 1 card circulating between the user and the storage, the user and the storage area. If there is a storage area, okay, this is the staging area or the storage area. This is actually the production line. This is the workers. So this is the card here. This card here. So they actually circulate between the user. This is user, and this is storage area. So once it's finished, they will send. Of course, there are delivery person. I mean, there is a forklift. If the part is big, you have to use a forklift, okay, or machine to deliver this. Okay, so basically, it is a signaling. I need parts, so you have to deliver. okay. User storage, and the other between the storage and the producing area, right? So there is this so-called two-cut system can also be used. Still Kanban, it's a Kanban, okay. Right, there is a calculation. I'm not going to go through this, okay, the number of Kanban cards or containers. You need to know the lead time, you need to know the amount of safety stock needed. So there is a calculation on number of Kanbans needed. It is based on this formula: demand during lead time plus safety stock divided by the size of container. So then only you can actually determine the number of Kanbans. In this case, it is containers, okay, the number of containers. So in this case, okay, you need to have 5 Kanbans or 5 what do you call containers to rotate between the production and also the storage, or the the person machine that actually going to deliver that. Okay, so number of Kanbans, in this case 5. Daily demand 500K, production line lead time 2 days, safety stock. Okay, so number of Kanban is 5. Okay. So small containers require very tight schedules, smooth operation. That means the smaller the lot sizes, the more difficult to actually monitor and control the exchange and also the delivery to the production line. Okay. Okay, that is Kanban. Okay, so you need a Kanban. That's now we say we need scheduling, Kanban. And then JIT quality or lean quality. Lean cannot work if there is no quality. If you want to ensure lean, I asked the question already just now. Okay, so if there is defective parts, lean will fail. JIT won't work. Okay, so there is a strong relationship between JIT or lean. Okay, the new book they say actually lean, lean quality, lean. Not they don't use JIT anymore. Lean quality. Lean will cuts the cost of obtaining good quality, because JIT actually exposes poor quality. Okay, because if you have very low inventory, if there is any defective, then production will be affected. So it will expose problems immediately, especially if n equals to 1. If you only produce one at a time and you need one part, so if you give one part, you must give a perfect part. You cannot give a defective part. N equals to 1. You only make one. So that is the best way to see perfection. Okay. Because lead time are shorter in a JIT system, okay, environment, so quality problems are exposed sooner. Okay, so that is the what do you call the results of implementing JIT. You will expose quality problems. That's what we want in any environment. We want to detect problems as fast as possible so that we can solve it. We don't hide problems. Okay, in any operations, in any production, you need to find out problems as soon as possible. Okay. Better quality means fewer buffers. So you don't have to keep extra just in case. You know, just in case. Have you heard just in case? This is just in time, okay?
万が一、もし何か悪いことあれば、
はい。悪
いことがあったら。
何？万が一。Just in case one defective, so we have one extra. Like just now I give example. I only give you one paper for tests. To do test, only one paper. But you say, oh, just in case I have one extra. So mudah ni. So just in case, we are not just in case system, we are just in time, okay? So we don't, that's why we don't keep buffer. Fewer Not to say zero buffer. Sometimes you need safety stock, but the safety stock is just enough, not extra. Okay, not extra, not waste. Then will allow JIT system, simpler JIT system to be used. Okay. Right. So I think it's also integrated with quality tactics. We need to use SPC. We need to empower employees. That means it is integrated. Any lean operations is going to integrate with total quality management as well. You cannot operate a company where only you are good in only processes, but you are not good in managing and also controlling quality. Excellent organization like lean processes, they will actually have SPC using. They empower employees. Employees will give ideas for improvement. Pokayoke. Okay. Say fail safe. Okay. Pokayoke is fail safe. And then expose poor quality with small JI lot and then provide immediate feedback for quality. Basically, quality excellence, quality management system is in place. Okay, you have a good quality management system in place. Okay, any questions? So, lean manufacturing actually was developed by Toyota, and specifically, this is what Toyota actually have built into their philosophy or their so-called TPS system, TPS, Toyota Production System. What are the pillars? I will share with you of this as different set of slides which I've developed for some training, not training, talk, okay, keynote address in one conference about lean sustainability, okay, lean sustainability. So TPS, their pillars is continuous improvement. Number one is they have this principle of continuous improvement. TPS cannot work, cannot function if there is no continuous improvement. It is everyone's job to do continuous improvement in Toyota, so that they will actually build a culture and value system that stress on Kaizen. Okay, that is how Toyota builds their organization. And one interesting thing is that Toyota managed to actually transfer this philosophy to all plants, all factories all over the world, even in America. Sometimes people say, why Toyota is able to transfer Toyota production system in America? We have a different culture, different work ethics, different management style, but they still follow TPS. This is in Western country. You see, this is not Asian. This guy, is this Asian? It's a European or American. This is American production line, correct? This is but you see compared to China or in Malaysia or in Japan, they don't wear uniform. Uniform? Suits, same. But in Toyota, all white. Okay. Not white, okay. It's not white. It's actually grayish. Honda is white with uniform, but this is no uniform, okay. So we Asians, we are more conforming. We like to, have standardization until, the way that we do things. And dressing. But it's okay, this is to us it's still not that good. But in Toyota, if you go to, have you been to your Toyota factory in Nagoya or in Itakoto arimasu ka? Nagoya. Huh? Toyota exhibition. You should try to go. There is a Toyota exhibition center in Nagoya, and they will bring you to factory visit. Then you can see how Toyota production system function in Toyota. Okay, so the first principle is continuous improvement, and then respect for people. People are treated as knowledge workers. Okay, so employees must be allowed to give ideas and innovate. Challenge, okay, challenge. Can I do this different way? Can I give ideas to improve, to reduce muda? Where is the muda? Find muda. Find muda. Then, reduce the muda. And engage mental and physical capabilities, empower employees. So this is, the kind of different style of managing. Okay, but this Toyota managed to use these principles and deploy or follow by all factories around the world. Okay, that's number 2. Number 3, standard work practice. Okay, standard work practice means work. It is when we study method analysis in the earlier chapters, method analysis, time study, standard time, normal time, and this movement. So that is part of standard work practice. Standard work practice means if you do work, for example, if you fix a tire, okay, it's a production line, okay, so the worker must have a standard operating procedure for installing the tire. Same method by everyone. You cannot have, Liang will do it this way. Tightening 1, 2, 3, 4 should be 1, 2, 3, 4. If there is 4 bolts, okay. So there is a standard operating procedure for all processes so that it will actually become consistent in quality, consistent in time, okay, and you can have productivity, constant productivity, right? So they always emphasize on standard work practice. Work shall be completely specified as to content, sequence, timing, and outcome. They treat internal, external customer supply connection direct. Okay, internal, external customer supply connection are direct. That means they have to actually deal and make sure the supplier also will have standard work practice because they need to synchronize. Synchronize. Do you know the meaning of synchronize? Synchronize or synchronize. 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 Like in orchestra, you go and see orchestra. There is a person playing violin. Correct. Someone play the piano. So it is like orchestra, synchronized. No, if you suddenly hear one, bad sound, then it will spoil the orchestra, damage the music. So you have to have this connection, direct connection between customer and supplier. Product and service flow simple, direct. Any improvement must be made according to scientific method. That's why we need to analyze the process. So things like 5W1H will be used. What, where, when, who, mohito suka. What, when, where, why ka? Why then lain? Or 4W, 4W. Why don't it? And 1H, how? what to do, where to do, when to do, who to do, how to do. Okay, so this is important, something important to recognize the difference between right. That this is an lean operation. So the whole thing is lean operations. Okay, the Toyota, this TPS, this is actually the whole operation. The whole operations must be synchronized. The whole operations must have waste reduction in the process. Okay, so that is the then only we say it is actually a lean operations. Okay, it is broader than JIT because I don't, you know, JIT is just one of the tool, just one. It's not good to use JIT. It's just one of the techniques. JIT, just in time. It's very narrow. The whole thing is lean operations or Toyota production system or lean manufacturing, lean of manufacturing, lean operations. So we will start with understanding what the customer wants, and it will optimize the entire process from the customer's perspective. Okay, so it will actually try to reduce waste as much as possible. Okay, so in this book, it doesn't talk about waste a lot. Okay, it doesn't actually emphasize waste, mudah. But in Japanese concept, it's actually three muri, muda, murah. There's, you know, actually three main things that must be understand. Okay.